Hi, I'm Natalie Robertson. I am currently a junior at Suffolk. I'm one of the McNair Scholars, and I'll be presenting my research from last summer, 2019, on the rate of escape of group A Streptococcus from within host cells. And you are watching this virtually because we are amidst stay-at-home orders for the coronavirus pandemic. So thank you for watching. Group A strep is a human pathogen that causes the widest array of human disease of any microbe. This can be things so minor as pharyngitis, or you might know it as strep throat, necrotizing fasciitis, which you may know as a flesh-eating disease, and streptococcal toxic shock syndrome. On average, group A strep takes about 500,000 lives every year. Group A strep can internalize in human cells and evade the immune system and evade killing by antibiotics. Recurrent infections may be explained by this, as many people suffer from recurrent tonsillitis or getting strep throat over and over again. In vitro, the cellular uptake of group A strep in human oropharyngeal keratinocytes, or human throat cells, what we were using here, leads to enhanced survival of the microbe in the presence of antibiotics. Egress, as I'll discuss, is the bacterial escape from human cells after they have been exposed to antibiotics. So this study is part of a group effort to address the 5 questions, though I am most often addressing the last 2 of how long can group A strep survive inside the cell? How does group A strep egress? What are the environmental cues for egress? For how long can egress occur? And at what rate is egress occurring? A bit of background about group A strep. So in macrophages, group A strep has been shown to live in vacuoles as a intracellular niche and evade detection from the immune system, and they are able to replicate. In the 1950s, penicillin had been used to treat group A strep, and at the worst, it was 10% of the time ineffective. And by the year 2000, this was 30%. So naturally, you'd expect that this is a case of antibiotic resistance, though there has never been an isolate of group A strep that was resistant to penicillin. So this led researchers to suspect that group A strep is hiding out inside of cells to physically evade killing from the antibiotics. If egress is occurring, how long can egress occur? At what rate is egress occurring? I address these questions by first setting up a growth curve of group A strep strains 854 and a mutant. They were grown in Todd Hewitt broth at 37 degrees Celsius, 5% CO2. They were resuspended in new THB at an optical density measured in a spectrophotometer set to 600 nanometers. The optical density between 0.06 and 0.07 was time 0 on the growth curve. And this was measured again every hour after. This was graphed on a logarithmic scale graph to show when the bacteria hit the exponential rate of growth, which was what was used to determine the mean generation time. Here, you'll see this growth curve of group A strep, and the straight portion of the line on this logarithmic y-axis shows the exponential growth. In this time, the average generation time in the group A strep 854 was 53 minutes. So that information was used to set up the full experiment of, in part 1, host cells, which are human oropharyngeal keratinocytes, or human throat cells, were raised in monolayer and split into a 24-well plate. When they reached an 80% confluent state, they were exposed to the group A strep, which from step 1 to step 2 was an hour and 15 minutes that the bacteria was left to internalize into the human throat cells. And by step 2, an antibiotic mixture of amoxicillin and gentamicin was introduced to the 24-well plate to kill all extracellular bacteria. Going to step 3, there was a plate of THB that the supernatant from the cells exposed to the antibiotic was plated onto. And at the point where there was no growth on that, that was able to confirm that all of the bacteria from this point on in the assay was from inside of the cells, not from the extracellular environment, because those were killed off by the antibiotic. And by step 3, the intracellular bacteria that weren't killed by the antibiotic are now left to, for 4B, the cells were lysed and the internal bacteria were counted. And for 4A, this is the egress assay. So the remaining wells of cells and bacteria were split up into 4A and 4B. The colony forming units for everything were determined, and that is what these numbers are. So the results were the plate with the supernatant on it, confirming that there was no extracellular bacteria at the beginning of the assay, is absolutely vital to confirming any of these results. And for the egress assay, we see, so only 0.12% of all group A strep internalized in the human throat cells actually, only 0.12% of total group A strep was internalized into the human throat cells. So less than 1% of all of the extracellular bacteria even got inside of the cells. So it's a very small margin, but with bacteria, we're speaking on such large scales that that is enough. So the egress assay was set up and measurements were taken every 30 minutes and plated to find the colony forming units per mil of media. So only 0.97% of internalized group A strep had egressed by 30 minutes in, and 1.66 had escaped by 60 minutes in, 2.3% had escaped by 90 minutes in. So we see an increasing trend. This could mean that egress, the rate of egress, is increasing over time, though this is only one experiment in triplicate. Therefore, this project needs to continue before results can really be interpreted. Future directions of it. So the questions that are raised by the egress assay are that the egress rate appears to be increasing, though because the group A strep's doubling time is every 53 minutes, it is possible that at the sample taken from the 90-minute mark, the group A strep could have already replicated inside of the cells if that's occurring. So it raises the question of, is the egress rate increasing or is bacterial load increasing after the antibiotic exposure because they've had the opportunity to replicate again? Other questions overall for the rest of this project is the mechanisms of group A strep that they use to exploit cellular pathways and evade detection are still unclear. Those need to be addressed. A rate of egress of group A strep from human throat cells still needs to be determined. There is anecdotal evidence that group A strep egress exists. However, there has never been any real analysis on the quantity of them and at what rate. There still needs to be further quantification of the initial intracellular bacterial load to compare numbers from the egress assay better, and still need to build on preliminary data of bacterial growth and doubling time to interrogate the number of and timing of bacterial egress. So these are the references, and thank you very much to Dr. O'Shea for being my advisor, to the O'Shea lab members, and to the McNair program at Suffolk University for all of their great support. Thank you for watching this virtual presentation today. And if you had any questions, this is normally where I would answer them, though when these are uploaded Friday the 24th, I believe it is, 25th, I will be on answering your comments live. So please have your questions in the comment section. Thank you.